In the previous nugget, we took a look at local area networking in the scope of the UCS B series. Guess what? We're going to change one letter. The L becomes an S. Let's go ahead and take a look at B series storage area networking concerns. Now, you might be in the position of being weaker in storage area networking, and that's because you have a great background in local area networking, like a majority of our students do. Well, no problem. Remember how easily we can refresh, and now would be a great time to refresh on your storage area networking foundational skills. How do we do that? Well, I recommend you do this. Go to your certification playlists area is a nice easy way, and we're going to go to Cisco certifications, and we're going to go over to the CCNA data center. Here at the CCNA data center related courses, you're going to choose 64916. That's DCICT. In the DCICT course, we're going to get a nice review of the foundations we need when it comes to SANs. I'd take a look at the MDS family so that you know what devices we're talking about here from Cisco System in the storage area network. Virtualizing storage, going to be very interesting for us. And then we want to go into storage options, fiber channel and more fiber channel, verifying fiber channel over Ethernet and data center bridging, connecting fiber channel over Ethernet. So plenty of great important nuggets in that DCICT course that you should review as appropriate, and you probably want to do it right now because we're going to jump right into a discussion of the Fabric Interconnect in the UCS system and the B series in this world of SANs, and again, you might need a brush up there. So an excellent and obvious question here is, what is the Fabric Interconnect acting like in our SAN topology? So here we have our Fabric Interconnect. The Fabric Interconnect is being treated as a fiber channel node with multiple ports and multiple fiber channel IDs. So the UCS Fabric Interconnect functions in that N port virtualization or NPV mode that we describe in our CCNA data center training here. So we have the UCS Fabric Interconnect functioning in that particular mode. Now, we have uplinks that go to the core switches. We often call these border interfaces. Now remember, one of the challenges when it comes to storage area networking is we are learning this new terminology, right? So flashcards can definitely help you. So we have our MDS core switch. We call it a border interface that's on the Fabric Interconnect. We also like to refer to this as our uplink, the same terminology that we used in the local area networking environment. This is a fabric port on this side, an F port, and it's an NP port on this side. What does NP stand for here? Well, it's a proxy node port. Okay, so we have a proxy node port on the Fabric Interconnect side, a fabric port on the MDS side. Now, what about our blade interface connectivity when we head down to the chassis? Well, sure enough, we call these blade interfaces in the SAN terminology for our infrastructure. We have virtual fabric ports on the Fabric Interconnect side, and this would connect to, here's our B series, right? It eventually connects to a virtual node port or VN port on the B series side. This would be like a fiber channel over Ethernet converged network adapter that we have inside of our B series. So we've got N port virtualization mode for our Fabric Interconnect. This creates our proxy node ports on the uplink side, and it creates virtual node ports or virtual fabric ports, on the blade interface side. There's our virtual node ports down on the converged network adapter. Please remember, if you need a review on these different roles of ports in a storage area networking topology, we have that information for you in CCNA Data Center. This is how it lays out for our important Fabric Interconnect in the SAN. Now, coming from our discussion of B-Series local area network connectivity, I'm sure you're definitely curious about how traffic from a blade server for storage fiber channel traffic, how is that pinned to the uplinks? Well, sure enough, each and every server link is pinned to exactly one uplink. There's a pinning logic built in which distributes our server links to the various uplinks, but it's very important that each server, you realize, is pinned to exactly one uplink. Now, do you remember in our previous nugget when we were talking about the LAN connectivity and specifically our Fabric Interconnect, we found that the Ethernet port personalities existed, right? Yeah, for instance, we could have an uplink port personality, or we could have a server port personality. We could have a monitoring port personality in the event of the utilization of the switch port analyzer feature for analyzing our data center traffic. Well, guess what? The same concept exists here in the storage area network. Let's go to our Fabric Interconnect A, and let's go to Configure Unified Ports. Do you remember this? We're going to give ourselves some fiber channel ports here. We're going to use this really cool slider bar. Remember, we have to configure our fiber channel ports in groups. So I'll go ahead and have these 8 ports here be fiber channel ports. Just absolutely amazing how we can do this. So I say yes, I say okay, and what's going to happen here is in a moment when that Fabric Interconnect reboots, oh, and it just happened, we're going to get 8 fiber channel ports all of a sudden, and here they are. Sure enough, notice we can go in and manipulate port personalities here. For instance, I can go in and configure as a fiber channel storage port. So sure enough, we are going to have different port personalities in the fiber channel world, just like we did in the Ethernet world. You could have a uplink port. Yeah, your fiber channel uplink. You could have a fiber channel storage port like we just saw. We could have a fiber channel monitoring port. So you're not going to have as much flexibility in the SAN environment, but flexibility and different port personalities nonetheless. Now, what do you think happens by default with your fiber channel ports in the UCS infrastructure? Yes, indeed. By default, they are your uplink ports. So by default, your fiber channel ports are uplinks. By the way, you can bundle them together. Okay, so we do have port channel support here. And something else to be aware of is we do have virtual storage area networking support. This, of course, is a Cisco invention, and therefore it is fully supported in the UCS system. So sure enough, this virtual SAN concept is very similar to our virtual LAN. We're going to go to the SAN tab in order to configure and support our virtual SANs. We have the vSAN 1. The default vSAN, here we can see it, and sure enough, it cannot be deleted, just like our VLAN 1. And sure enough, each virtual storage area network is configured in either a global fashion, just like we saw with our VLANs, or you could be Fabric Interconnect specific. Just like with our VLANs, Fabric Interconnects are typically going to share the layer 2 domain and those same virtual storage area networks with each other. Now, you ready for something hugely important, both from a production environment and from a Cisco certification environment? Let's talk about, let me grab my pen again, let's talk about the fiber channel over Ethernet VLAN. This VLAN is used for carrying our fiber channel over Ethernet traffic. It is a special VLAN in that it cannot overlap with any other VLAN that you have in your environment. Listen, it is a best practice to dedicate an unused range of VLANs for our fiber channel over Ethernet world. So when you're designing the infrastructure, you could say, all right, look, we need 50 VLANs. So we're going to go ahead and we're going to just give some room for growth. We're going to say VLANs 1 through 60 are our quote normal unquote VLAN traffic. And then you could say, I'm going to go ahead and dedicate VLANs 61 through 70 for fiber channel over Ethernet VLAN purposes. So we want to make sure we have this dedicated range of VLANs that would be used for the specialized fiber channel over Ethernet functionality. Extremely important. Now, when we were focusing on the LAN side of the equation, we talked about the NIC and we talked about how we virtualize the network interface card, right? Well, we're going to do the same thing in this environment, except it's not a NIC that we're dealing with. It's a virtual host bus adapter. And sure enough, we virtualize the heck out of this entity. In a LAN environment, our virtual NIC had MAC addresses that we would virtualize and assign to it. Well, sure enough, in the SAN environment, it's our worldwide names. We're going to virtualize these. We're most likely going to have these in pools that we are going to draw from, and we are going to manage all of this through service profiles. So much of this nugget has followed from our discussions of LANs, hasn't it? And that really does make it simple for us when we're studying this material. To further make our point about how this follows the LAN stuff that we studied, remember how in LANs we could create pin groups in order to statically pin particular servers to particular uplinks? Well, here we are on the SAN tab. We're in the SAN cloud area, and sure enough, we can do it in the storage area network as well. We can pin particular devices to particular uplinks, and this is very simple through the creation of a SAN pin group. Now, before we get to our final exam, there is something additional I need to talk to you about with our Fabric Interconnect in a storage area network environment. We said it's going to do NPV mode by default. Yeah, and this is the most common implementation. But for the complete story, and if you're interested in certification, please realize that you can instead run the Fabric Interconnect in what is called fiber channel switching mode. Now, when you do this, the Fabric Interconnect is not viewed as a node. It is viewed as a switch, and that means you are going to consume one of those fiber channel domain IDs. This is a bit of concern because, as you know, there is only 239 possible domain IDs available within our fiber channel addressing scheme. So if you introduce a 6 or 8 port fiber channel switch, this can really severely limit how large your storage area network can grow. We know in the N-port virtualization mode, the default, our Fabric Interconnect appears as a fiber channel switch upstream as an actual node in the fiber channel environment. So we don't consume that domain ID. Also, please keep in mind that in the default NPV mode, fiber channel services are not operating. This means that the hardware of the Fabric Interconnects is not going to be as severely loaded as it is when we are in the non-default fiber channel switching mode. Now, if we were in the fiber channel switching mode, we wouldn't have the NP port to F port connectivity that I described earlier. Let me show another uplink here and realize that it would simply be an N port to an F port when we were in that switching mode. So, a non-default configuration, not often seen, with scalability concerns, is to have the Fabric Interconnect function in the fiber channel switching mode. I bet in the UCS management system, this remarkable conversion of the Fabric Interconnect's role, I bet would be just a simple click of a button. Let's go in and see if that's the case. So here we are back in the UCS Manager, and we'll slide over to the Equipment tab because we're talking about our Fabric Interconnect. Here is our Fabric Interconnect A. We saw earlier in the previous nugget where we could set the Ethernet switching mode. Remember, we are in end host virtualization by default, but we discussed the ability to flip the switch into Ethernet switching mode, and then we pick up spanning tree protocol. Now we conclude this discussion by taking a look at how easy it would be to set fiber channel switching mode and to leave that end port virtualization mode that is the default. Now, many of my students have given me feedback about how much they absolutely love the exam reviews that we do, our final exam time in the nuggets, and I'll really work on this moving forward based on your feedback. Thank you so much for that. And one of the things I love about final exam time is it'll often give me a sanity check on mentioning things that I really needed to mention from a certification standpoint. We're at one of those times now. You're in a fiber channel switching mode. What is true regarding SAN zoning? So look at this, we're in the non-default mode. Instead of the default NPV mode with the Fabric Interconnect, we're in this fiber channel switching mode. What about SAN zoning? Well, remember what SAN zoning is. It's logical configurations or groupings of our storage area network equipment over a physical infrastructure. We often do this for security purposes, right? We can compartmentalize blocks of our physical storage area network environment into these logical configurations. I love it. So, what's true about SAN zoning when we switch over to fiber channel switching mode? There is no zoning required? Aha! This would be true if we were in the NPV mode, but we're not, so it can't be A. B, you use default zoning or a zone merge in order to get the zoning to the switch. This is absolutely correct. B is our correct answer. But remember, we'd never stop here in the exam. I'd want to sanity check C and D. You must locally configure zoning. No, we cannot do that when we're in fiber channel switching mode on the Fabric Interconnect. And finally, none of these options are correct. No, there was one that was correct. It was option B. When in doubt in your exam environment, never choose the none of these options are correct option. This just means the exam author ran out of incorrect answers to present to you. And that's exactly what happened with me, by the way. Well, listen, I am just so thrilled that you joined me for this particular nugget. I hope it has been informative for you, and I'd like to thank you for viewing.